Yaroslav wrote code to access the Kinect sensor to get data out of it. And we are planning to start getting the pictures right after this lecture. And then we can start implementing the algorithm further.
And actually the hardware, so just a tripod with the Kinect and a rotating table with the speed of about 2 rotations per minute.
As I know, Murtaza have some databases with the Kinect, image databases with the Kinect. Do you use them or not?
We don't use this as a specific image database, but I found some other database that I used for doing this filter thing. So yeah, we are using Kinect images from the database.
And you know that when you want to construct a 3D image with high probability, you missed some points in your image. Do you have any plan to?
That's why our final point is the interpolation. So we have the point cloud, and then we use these points to create surfaces, and this is how we do it.
Yeah, so there would be, of course, some not accurate results, but depend on the software, hardware accuracy, and the rotation.
Yeah.
And so there are also aspects.
And also the object should be like a good one.
Yeah, because for example, if it's round, then the Kinect camera just misunderstood the reading of the edges, so it's can't really distinguish. So it also depends on the application itself.
Okay. You have a question? Good. No? Thank you. Good.
Project actually about digital face makeup generation. So just like as it says. So
Before you start this, we are not your supervisors, we just the lecturers.
oh,
Don't
okay.
supervise.
So actually just we'll give introduction and some about the workflow we are planning to go through. So for example about the project, for example, the idea if you wake up in the morning and that you have interview on Skype for after 3 minutes, we won't convert to private, of course, so we won't do that right. So actually what we are planning to do, first we make face detection, and we have like 2 ways to do it. First way actually use machine learning techniques like neural networks or deep learning. And the other way actually, when we are researching, we find that most people are using a hard-like feature, which is actually defining a window, and then after that they have features, like for example the nose will be like 2 black and 1 white rectangle in the middle, and then they're trying to fetch this model to this window until like, and the window will move over the picture until they find this feature that are required. For example, the eyes and mouth, nose, stuff like that. Okay, face segment. After that, after detection of the face, after that will be like face segmentation, which is actually there is Viola-Jones object detection. It also depends on hard-like feature as well, actually. So, but the problem actually and the main challenge for both of these methods, which is accurately actually define the segments, because all these methods give you a rectangle. It won't give you like accurate borders for example, the eye or the mouth. The mouth is not rectangle, also the eye. So this is actually the main challenge. And I believe you have a video that's showing the face detection using. Okay. How it's like detecting, it's like just detecting a rectangle of the face. It doesn't give much detail. And there is another one showing like how it's really working. I mean, like how it detects the face. If you see like at each time there is like some like this rectangle, some or features. Let's try, for example, this one actually, this type of feature, black, white, black. Just remember that this is a nose. And okay, never mind. Faster. So in the end, it will detect the face.
We assume that is detected.
Yeah. And then actually it will just find the face depending, like if all these features are satisfied, it will find the face. After that, after we like just find and solve this challenge, actually will be like a color modification, which right now actually we're thinking like taking the average color. And there's another thing, because like when you put makeup, it's like okay. But for example, when you put there is a makeup, it doesn't always exist at the same degree at all these places. So we have like to distribute this color like to be somehow like I don't think even averaging like give it accurate description about it, because it's not accurate. It has to be like some distribution and stuff like that. Then actually there is. Okay, actually there is like two things that I found like this one actually, which is about skin detection, because if you like we want to give a certain like enhance the skin color, for example, we have to detect only the skin without eyes, without anything else. This is actually a simple way to do it, but this is actually a simple way to do it, but it has its own flaws. If you notice, actually, it got this color.
Not accurate.
Yeah, not very accurate actually. Get the skin, but actually there is another problem with it. It's like deterministic way to define the skin or to find the skin in the image. Because actually they define a domain for the colors. For example, if the color in this domain for red, green, blue, and red, green, blue, I'll give it lower and higher domain for all these colors, and then it determines like, okay, give me show all of those colors in this domain. So, for example, if you have like high saturation or like there was, it will be different from like low light to high light, stuff like that. So, more accurate. And this is actually using higher classifier, but this one actually is more accurate. It's like detecting the face and then detecting the mouth area and then detecting the lips. Same, using the same method actually. So probably we'll use this method as a start and then trying to find some better methodologies just to be more accurate in determining the parts.
Yeah, so probably one of the most challenges is to find the edges of the particular region, like mouth or eyes or something. Yeah. And currently we are just exploring the algorithms that are available and like how to use them, how to merge everything together.
Question? You will use hard classification for the detecting the face and mouth and something like
We'll
this.
use it as a start. After that, we really need to find some method to, because actually we don't need, for example, when we find the eyes, we actually don't need the eyes, we need the
Edges of the
Yeah, we need
Yeah.
the edges of the eyes in this area because
But why you don't use Viola Jones for the detecting a face and object in the face for eyes, nose?
actually
Because I saw in your slides you wrote that for the face detection you use HAR classification, and for the object detection you use Viola Jones. But you can easily use Viola Jones for
yeah for both and actually
both.
actually when I opened when we researched for Viola Jones as well, both of them actually I mean Viola Jones is more advanced. It's more it's more computational enhanced, and but it's depend on hard classifier as well. I mean, hard feature. Like,
Yeah.
okay.
But in general, it doesn't matter which method you will use. But if you can get the better result from the hard classification, you can use this. But if you can get the better Viola Jones, it will be better.
Maybe we will like experiment with those
Yeah, you have to
tools
test on this. Yeah.
and see what to get the results.
People have any question? No. Thank you.
Hello everyone, I'm Abdelaziz and my group mate is Fatima. We're working on stereo depth map, and we've read a lot of literatures on this. I actually worked on this last semester in the other course, but it was just a semi-depth, but this is a full depth. So I will say maybe the workflow, the steps are not too much, maybe just to acquire image and to do the matching, which is the difficult task to us in this project, and to determine depth. We wanted to use the Kinet camera. We went to Montiza and we took some pictures, but we found out that for this project we can't use it because the Kinet already has the depth image. Like maybe it's already the solution to this project, but we decided that we'll just use normal camera and do the depth estimation ourselves. So right now we have the images, but kind of they are not too good. Maybe the camera calibration is not too okay. But basically, the step we plan to follow is that once we have the images that seems to be okay from both cameras, then we want to do the stereo matching, which is the main task here. So what we do is that we have a polar constraint in the two images to match each pixel of the two images so that we can estimate the depth. There are actually many algorithms that we found on this project, though they are good and also they have some shortcomings, but it's our desire to maybe to develop a novel idea to solve one of the problems of the algorithm. But well, I don't know, maybe because of time, maybe we will just try to do something, and perhaps maybe on our own personal terms we can work on it more later. But maybe I want to ask you, the challenge is that it's so wide during this stereo matching. We have as read literature, we have the RANSAC, we have the SIFT, and well, to us the simplest one here is maybe to use triangulation. which maybe before we took the picture, we have like some points which we try to match on the other side. We don't know if it will be a novel idea. Basically, that's what we plan to do. I don't know. Yeah.
Question?
I think it's more related to Martin problem, the Martin's projects. Just that maybe they don't need to estimate the depth. I guess maybe you can use the Kinect camera, but we acquire the image and estimate the depth. Also, with Kinect you already have some depth, the depth estimated in the Kinect.
Do you have, is there any available database in the internet, or you have to make to generate the database,
There are
your
actually
own
available
database?
databases on the internet, but we actually intend to generate output to work. Because if what we agree with Fatima is that maybe we try to write a code for database on the internet. If it works, then we slot in our own database. If it also works, then
If you want to make or generate your database, how many cameras do you have planned to use to take the photos?
well, maybe minimum of 2.
Minimum.
Yes, the left and also the right.
Okay. Good luck.
Thanks.
Hello, our project is bowling ball detection. Now it seems quite simple, but turns out it actually isn't. Well, first of all, maybe about the applications. One would be to we would like to have a camera in the ceiling of the bowling alley and detect the bowling ball, and then also have a projector to project some flames or something behind the ball, so it's like it look very nice and more attractive to people. And also the other application is for professional bowlers who have them in their target practice. There we need quite accurate estimation where the ball actually is.
During this course, we only do this
Ball
inspection, but
we don't focus so much on having it really accurate, but we would like to have a robust system, because also the bowling balls are in different color and the light changes also by the time in the alley, so we would like this to work in various environments. So what we have done so far is
Can you please turn off the light? Then we can. Thank you.
this is we have written it in Python, and it basically it's just a simple motion detection. We have a reference plane and we subtract it from each plane, and then use some threshold to get the moving object, and also some morphological operations to have a nice contour. And then we have this simple contour of the object currently. So the challenges are that we have some artifacts on the bowling lane, which also for some reason classify as a bowling ball for this program currently. And also, as you can see, that these images are quite blurry, because the balls are moving quite fast, up to 40 kilometers per hour actually. So we are planning to use some motion
question. How much is the distance between the camera and the line of bowling?
Preferably as high as possible, but these pictures are
No. If you want to detect the ball through the line, you have to put the camera in highest distance, and with high probability you will get one more ball that is in another line, because when you increase the distance of the camera to the line with high probability, at the same sense we have 2 or maybe 3 lines. And do you have any plan to consider this problem or not?
We have done some videos also with 6 lanes on one image and 6 bowling balls, so we are planning to make multiple object detection also. But currently we just started with a single ball and video close-up.
It means you will. It's the movie, yes.
Yes.
How many frames do you have in this movie?
I think it was 24.
20, around 20. It means that in each frame you will detect the ball, yes, or for example, in 5 frames you will detect this.
right now we don't know it. It's,
In this current.
in this demo, we just
have just
do it some frames out of the video and detect from like from simple picture.
On the video, we only had the ball in the image for like 4 frames.
And one thing that, because as you know, the size of the bowling ball are different. Can you apply your algorithm on, for example, the 8 kilos ball and the same for the 14 kilos or 15 kilos ball?
Yes, because the size is the same, it's only varies in the weight.
Yeah.
But it might be a problem if the ball color is exactly the same as the lane, or very close to it.
But why you don't use this grayscale image instead of the color image?
No, actually, we do use grayscale, but still, if they're very close to each other, then the motion detection maybe doesn't.
No, but actually, if you use some edge detection, such as, for example, canny edge detection, in the grayscale, you can easily detect the edges of the ball, and I don't think that you will have any problem by using the edge detection to detect the edge of the ball. But in general, it's up to you. If you want, you can do it in the color. But I think the easiest way is to work on the grayscale image.
But with these edges, it is also that, as from this picture, you can see that it's the ball is moving and the edges are like blurred because of the movement. So
No, but if you want to use the edge detection, you have to do it for each frame. It means that, for example, for frame number 2, we detect this edge. For frame number 4, we detect this edge, and we have to track these edges together to find the movement of the ball. But it's just a suggestion. It's up to you. Any question? No. Thank you. Good luck. Henrik and Jakob.
So we divided our work in three areas, as I said before. Firstly, detecting the license plate number. So to do this, we are going to do some image processing, character extraction, and character matching. In the image processing stage, we are doing some morphological image processing, and also we try to extract the number-based area with the Viola-Jones algorithm, so we can get the number-based figure for our photo processing. And actually, we have some example codes for our own database that we made. So, firstly, if I have image like this, then with Viola-Jones, we want to crop out this area, or first detect, and then crop out this number bit area. Then we get something like this, and then this will be fed into our future further program. So in MATLAB, we're going to input this picture, then we will convert it in binary form, and then with some processing we get a picture like this. So here you can see the characters and the numbers and letters, and also there are this OD mark, OD sign or mark logo, and some white square. But these we are going to eliminate. First we're going to take these things from this picture, and then going to eliminate them and get only the license plate area. And so the final result will be written into program. And this is the part we have already made. In order to match the letters, we predefined, actually used predefined numbers from that we found during our research. And here are numbers, for example, where the inner areas are not filled, and usually when we use this detection program, it fills the inner areas, so we also have letters and numbers where the inner areas are filled. And then we, if we found the letters on our license plates, we are going to find the correlation with these letters, and the nearest letter will be written into the text file. Well, next thing we have to do is mark detection. So for this we want to find the logo of the car that can be used for detecting the car's mark. So we also want to extract this from the picture. Maybe we can use the Viola-Jones again to do this, and then we can do some sort of pattern recognition, or do also this kind of correlation if we have predefined our logos like with the letters. So we are still deciding which one we want to do with this thing. And finally, we have to do the color detection. So well, we had many different ideas. The simplest one was that if you can detect where the car is, or if the cars, we know that in some place of the picture, car as always has a color, then we can just take one pixel and determine what's the color of this pixel. But there is a problem that when we take the pictures in daylight, then the different parts are in different colors, and usually the cars are shining, and maybe if we take a picture with gets better and the car is black, then can detect black color. So right now we are thinking that maybe we can somehow, if we can extract the car portion in the picture, in some pictures the picture mostly is the car, but we can detect which is the more dominant color in the picture, and maybe with this thing. But in this part, if you have any suggestions, then we are open to them, because we can come up with a very good reason that we believe that it's going to work perfectly. Because in some cars, maybe like here, it's a lot of white and not a lot of green. We can understand that it's a green car by our eyes, but the sky is white and the car color is white, so it's hard to know if this is green car. One other way is that we can check the picture for all different colors, we check it for blue, for green, for yellow colors, and if we find it, then we can see where is the area in the picture where we find these colors, and maybe with that thing we can, if these pixels are in the middle of the picture, then we can maybe estimate that it is a green or red color or any color. And one initial thought was that if we find the number plate, then I believe every country has their own car databases, so if you know the number plate, we can just check what is the color and the mark and I don't know, manufacturing year. But that's just if maybe after that. Our progress, I believe that most of our research is done. We have found some code examples. This number plate recognition was done mostly by combining different codes, and it seems to work for us. We have to do, we captured pictures, about 20 or something of that cars, and we have to do programming and those that. That's it. So if you have any suggestions for
idea. When you already detect where the number plate is, then you can also detect how big the number plate is in the picture, right? So you know about how many pixels up from the number plate car body is basically. So if you make it like some correlation based on how big the number plate is and how many pixels up from that number plate, the color of the car would be some area.
well, it's a good idea. Actually, I thought about this. But when I look at this picture, for example, there's like the black area before the real color, and in some pictures it depends on the model of the car. So,
Okay.
so in some cases I believe it works, but I don't know if it works for all.
Any other idea? Question?
You can also try cutting out the black part.
Yeah.
Cutting out black is easy.
Yeah. This is a part where we have to think. So it's a good idea.
Are you working in the RGB color space?
For different things, we are doing it in different workspaces. For example, with the number plate, we are
No, for
working-
this.
We think that we are going to do it in RGB, but I found that some color detection is really good in HSI workspace. So we have to.
My suggestion is that for detecting the color, it will be better if you work on the HSI or CBCR color space. Then we can maybe get a better result. And one more question: can you please show the plate number, image of the plate?
I think
Yes. How you remove this EST from the left side of the
Okay,
plate?
it takes an area, it's like first we take the picture in, and then we find the letters, and if the letter is too small, then it's not accounted, like the area where we take the letter area. If it's too small, then we don't account it. So it's not taking small letters. Right now, it works mostly pictures with this size. If you maybe zoom a bit more in, then it is going to take the small letters. So it's really important that we use the Viola-Jones and do it from the right side out for us.
Okay. Good luck. Thank you. Gustav and Egils remain. Gustav, can you please? Can you please stay for 10 minutes and Gustav talk about the project and then you will.
Hi, I'm Gustav. I'm talking about my project, which is about the automatic MRI build documentation. So, MRI, who doesn't know, is magnetic resonance imaging. It's an non-invasive procedure, so we can see what's going on inside people without cutting them actually up. So this is someone's head. Everything I'm talking about here today and will be doing within this project is based on